In earlier videos, we had topics dealing with finding the critical numbers of a function, finding relative extrema. In this particular video, I'm going to look at an application of a relative extrema. So here's the example I'm going to look at. The concentration C of a certain drug in a patient's bloodstream T minutes after injection is given by this function C of T. Determine the time at which the concentration is highest. So determine the time at which the concentration is highest. So that's actually the same as really the critical number. And then if they ask you for the maximum, that would be the function's maximum value. But here basically it wants the location of the maximum value, which is what I did in the last video. In fact, I actually worked the same function or the same problem out, except in that particular example, this was just a general function. In this particular case, it represents concentration. So in either case, we have to find the critical numbers to solve the problem. So to find the critical numbers, as I showed you in previous videos, we have to find the derivative. Okay, so we want to find C prime of t. That's the derivative of this particular function. And so since it's a rational function, it's going to involve the quotient rule. So the derivative of this function then will be this. In the denominator, I'm going to have the square of what's in the denominator of the original function. So in the bottom here, I'm going to have t squared plus 25 quantity squared. And in the numerator, I'll have whatever's in the denominator, which is t squared plus 25 times the derivative of what's in the numerator. Okay, the derivative of 50t with respect to t is 50. And then the quotient rule is what I'm using here. Then you have a minus, and then whatever I have in the numerator, which is 50t, times the derivative of what's in the denominator. So the derivative of t squared is 2t, the derivative of 25 is a constant that would be 0, so this will be times 2t. And then I simply simplify this out. So in the bottom, I'm still going to have the t squared plus 25 quantity squared. And then on top here, I'm going to have, I multiply through here by 50. This will give me 50t squared. And then on this term here, minus 50t times 2t is minus 100 t squared. So I got 50 t squared and minus 100 t squared is a negative 50 t squared. Okay, so again that's coming from this term here, 50 times t squared and 2t times minus 50. So basically again I have 50t squared minus 100t squared is minus 50t squared. And that's going to be plus, and then 50 times 25 is 1250. Okay, so this problem basically is dealing with a relative extrema. So for the relative extrema, we need the critical numbers of the function, which are those numbers in the domain of the function for which the derivative is 0 or the derivative is undefined. Well, since we have t squared plus 25 in the bottom here, quantity squared. There's no values that'll make this 0. That's where it would be undefined. So the only concern we have then is when is the numerator 0? Because so that's when the derivative is 0. So I take this minus 50t squared plus 1250 and set it equal to 0. So I would take the minus 1250 and take it over, divide by negative 50. So basically I'm going to have t squared will equal to negative 1250 divided by negative 50. So this is the same thing I did in the earlier video. I get t squared is equal to 25. Okay. 25. So t then can equal, take the square root, plus or minus, can equal minus 5 or a 5. So negative 5 or a positive 5. Now in the earlier video we had the same function, except there it was just asking for critical numbers, so we said the critical numbers are negative 5 and 5. Okay, but in this particular case, since I'm dealing with a specific function here, dealing with concentration, and I'm trying to find time, I can't have a negative time, so I had to reject the negative 5. So the only answer that I can use is the 5. Okay, so then I simply test this out to see whether this leads to a maximum, which is what I'm looking for. So I take a number. I'm looking for the sign of the derivative. So remember the way it works. If at a critical number the derivative changes sign, if it changes sign, we have a maximum or a minimum. If it goes from plus to minus, the graph goes up and then it comes down, we have a maximum. If it goes from negative to plus, the graph is falling and then rising, we have a minimum. Well, in this particular case, if I pick a number less than 5, say 4, and put it over here, and this minus 50t squared plus 1250, if you do the calculation, that's going to come out to a negative number. Now if I pick a number slightly larger than 5, I could go 5.1, but let's just pick a whole number. They say 6. Put a 6 there. 6 squared, 36 times a negative 50, and then add 1250. That's going to come out. And I really want this to be, this will come out to a plus. Okay. If I put a 4 here, 16 times negative 50, add 1250, that will come out positive. Okay, so this should be a positive right here. Now to the right of 5, if I select a 6, put a 6 over here, 6 squared, 36 times negative 50, plus 1250, that will come out to a negative. So basically my graph goes like this. It's rising, it rises, and then at 5 it falls, so I do get a maximum. So it says, so the maximum occurs at 5. Now if I wanted to find the relative extrema point, or the relative maximum point, the point would be 5, and then I would put a 5 here where in the original function 5 times 50, and then over here in the bottom 5 squared 25, and 25 is 50. If I add 50 into that, I would also get 5. Okay. So the relative maximum is 5. Okay. The largest value of the function is 5. The relative maximum point is 5 and 5. So this is asking, determine the time at which the concentration is highest. Okay, so the first component here is the time. So that would be 5. So the answer to this then, what they're asking is the time. So this would be t is equal to 5. And that's in minutes. Okay, so that would be the answer to this. X is equal to 5. And if they ask you for the actual concentration, that would also be 5 in this case, 5 units. Now if we look at the actual graph, okay, so let me enter the function 50 divide by x squared plus 25. And then I'm going to do a zoom 6. Okay. So this is the way it goes. So notice the way on the left side, here's where the negative 5 is. So at negative 5 and 5, there is a relative negative 5 and negative 5, I should say. At negative 5 and negative 5, there's a relative minimum. And over here on the right side, at 5 and 5, there's a relative maximum. And then, of course, we're only interested in positive numbers since we're dealing with time. So the maximum occurs right here, okay, at 5 and 5. So if you look at your table, you can verify that also. At 5, it goes to 5. Okay, if you want to look at the other side, at negative 5, it goes to negative 5. Okay, so that's an application of the relative extrema. So again, for this particular problem, the answer would be 5 minutes. Determine the time in which the concentration is highest. It's 5 minutes. And if it asks, what is that maximum concentration? Well, in this particular case, it's also 5. Okay. The first component gives you the location, and the second component gives you the actual value of the maximum, or in some cases it could be a minimum, depending on what they ask you. Okay, that concludes the video. So again, if these are helping you, please subscribe, and any suggestions, please post them, and I will consider them, and we'll see you in the next video.